All right, the compressor, second part of the refrigeration cycle. Now the compressor sucks the heat-laden vapor from the evaporator and it increases the refrigerant pressure and pumps it into the condenser. Now, again, this is counterintuitive when it says heat-laden because when we looked at the last example, that vapor was at 40 degrees. It doesn't seem like it's got much heat in it. But remember, heat is molecules in motion, and the all of the heat energy that was required to change that refrigerant liquid into vapor is now trapped in that vapor, and it's in that vapor until it condenses down. So it is all those molecules in motion bouncing up against that refrigerant, causing it to change state, are now trapped in the refrigerant. Don't forget that. All right, so the compressor reduces the low side of the system and increases the pressure on the high side of the system. It's pretty much the heart of the system, and it's what pumps the refrigerant through the refrigeration cycle. There's several different types of compressors. You can read in your book how they operate. Mechanically, they are all different, but they all accomplish the same thing. And we're going to use a piston type compressor here. It's a little bit easier to understand. All the other compressors do exactly the same thing, just mechanically they're different. So here is the suction vapor that is being sucked into the compressor, and the first cycle is the downstroke of the piston, and as that piston pulls downward, eventually the pressure inside of the piston itself will decrease below the pressure above the valve, which is right here, and that reed valve will open up, and this begins to pull in the heat-laden vapor from the evaporator. So it pulls that in and sucks in that heat-laden vapor. That is the first part of the cycle. All right, so the second part of the cycle, at the bottom of the stroke, right here, the piston stops. At that point, the pressures equalize and the suction reed valve closes. And now we have a certain amount of heat-laden vapor right there inside the piston. Now we have to go back to our gas laws to think about this. We have this much volume right here, and now we're going to take this piston and we're going to start to compress the vapor. And you remember from your gas laws that if you are in a container, a fixed size container, and you compress the volume of gas, it increases the pressure as well as increasing the heat, because those molecules in motion that are bouncing around up in here in this piston bounce around at a certain rate. But when you start to compress this gas that has those molecules have less area to bounce, and they start to bounce faster, and they bounce off of each other, and the pressure increases, and so does the temperature. So now we take this heat-laden gas that's somewhat cool and we compress it. It still has the same amount of heat, but it raises the sensible heat and it raises the pressure up. And at a certain point, the pressure created by this piston overcomes the high side pressure, and it opens up the outlet valve, or the reed valve, that's up here at the top. And that will start to push that refrigerant, now that has been increased in pressure, it will start to push it out into the high side of the system. So now let's go on to the next. So as the high side gas starts to get pushed out, eventually when the piston reaches the top of its stroke, the pressures equalize and the reed valve will close again. And then what this says is, as you start to pull, there's still just a little bit of hot gas right here. As you suck down on the piston on the downstroke, it's going to start expanding that hot gas, and eventually the suction valve can now open, and we continue to go through the cycle over and over again. But the key to this is when we are in the compression cycle, let's see if we can zoom in here. Okay, if we're in the compression cycle and we have taken the vapor from this amount of volume and compressed it down to a very small volume, we have increased the pressure and at the same time increased the temperature. This is key. So at the intake, our vapor is 40 degrees, and at the discharge side, depending on what the temperature is, it's going to be up there in the 150, 160 degree range. Okay, so here's what we have coming into the compressor. The vapor is at 60 degrees in this example, at 69 psi G. It gets compressed into 278 psi G gas, and what that does is that increases the temperature of the refrigerant. Now the heat that's inside of this vapor right here is still contained inside of this vapor. All we've done is increase the pressure and thus increase the temperature. The other thing that happens is this cool vapor comes in here. It also sucks some of the heat out of the motor and cools the compressor. So it also picks up a little bit of heat from the compressor, and it's a dual purpose here. All right, so that is our compressor. This is the heart of the system. One thing to remember, we have a low side and a high side of the system, and the compressor separates the high side from the low side, and there's another component that does it on the opposite end. But right here we have a low side on the compressor and high side on the compressor. So all it does is compress heat-laden vapor into higher pressure, thus making it a higher temperature. We get to the condenser, you'll find out how this all comes together and makes sense. So if you have any questions, any comments, if this does not make sense, please let me know on the forum or shoot me a private message, and I will post some more explanations. Not everyone gets it the first time around, so don't worry if you don't. And I will see you at the condenser.